Alright guys, this video is going to be on the lab. This is the lab you guys should be starting today. What I want to do is go through the instructions so you know exactly what it entails and what is required of you as you're going through. So that way you kind of have a good idea as to perhaps the best way to go about it. Alright, so I'll read through it with you guys. The objective is to find if the sequence that vectors are added in changes the resultant vector. Okay, so the problem. Captain Bartholomew Roberts, one of the most successful pirates between 1719 and 1722, captured more than 400 ships off the coast of West Africa and Canada and the Caribbean. This goes along with, just the other day when it was Talk Like a Pirate Day. One of Roberts' most profound qualities was banning his crew from gambling due to his strong religious beliefs, which would unfortunately cause subtle hostilities between him and various crew members. To his dismay, after hiding one of his treasures off the coast of West Africa, a disgruntled deckhand by the name of Blackjack Stanford decided to rearrange the sequence of steps to find the treasure so that it would become untraceable. So now Captain Bartholomew Roberts needs your help to regain the sequence of the steps to finding the treasure. One scientist by the name of Captain Rosenstock previously suggested that the sequence of steps are taken does not matter. However, he never took my class. Your job is to check to see if his assumption is correct. Best of luck. Alright, so here's what you're going to need. You should have everything in the packet of information that I gave you for this lab. Hopefully you grabbed this from the back crate. So the materials, you're going to have graph paper, protractors, and rulers. Rulers should be available. Mrs. Maddox should have got that out for you. You should have all of the rulers out. You should also have the protractors ready too. In case can't find them, they are once again in the top drawer of my desk on the left-hand side. Should be a box labeled protractors. Can't miss it. Okay. So number one, we're going to set up Cartesian coordinate system that includes north, south, east, and west. Just use what you're normally used to, never eat soggy waffles. Although soggy waffles with syrup actually taste kind of good. A little bit of butter, a little bit of syrup mixed in. Phenomenal. Anyways, consider north as positive y and east as positive x. Number two, draw your vector route number one by choosing an appropriate scale. So that's what we're going to be doing on the next slide here. And make sure that the vectors are all drawn to scale. That is like super important. If you don't draw them to scale, that is not going to make this lab really nice for you. It's going to make it a little more challenging. Okay, so be sure to avoid scurvy as well. So make sure you're eating all of your oranges, all of your lemons. Get that citric acid and vitamin C in your system. Okay, number three, compare the final locations of the route by measuring the distance from 0, 0 and the angle from the east axis. I only want you to measure from east. I don't care if it goes over 90 degrees. I just want you to measure what that angle will be from east. That way, I don't have to check like 4, 5, 6, 7 different angles. I can check just one. All right. Also find the magnitude of the hypotenuse graphically, meaning no math. So that's why I want you to be as exact as possible when you are drawing these to scale. And then change the order of the vectors and compare the two resultants from each orientation. So number 5 says proceed then to routes 2 and 3, which we'll do a little bit later. This time we're going to actually just draw them first and then find the resultant in an angle. So you don't have to do any of the math for those ones, okay? For the first route. For the second route, however, you can read number 6. Then it says you will also need to mathematically calculate the resultant and angles using your steps. So for route 1, you do not have to do any math. So you guys listening, right? Route 1, I should not see any math. You're just drawing two different variations. So you're going to draw those vectors, then you're going to rearrange the order. And I'll explain it whenever we go through it. Routes 2 and 3, I want to see all the math. So adding vectors. So remember finding your x and y components of each, and then kind of going from there. All right, so let's go ahead and get started. I'll be able to select my pen and okay. I'll have to do it again probably though. Okay. So, hopefully this will switch to the next slide. Sometimes it takes a little bit of time just because of the first time opening up Notebook. But basically what we're going to do is we're going to start on Route 1. And so Route 1 I can see, actually I just need this guy. Okay, so Route 1 is going to have 5 vectors. We got 50 meters north, we have 70 meters east, 30 meters south, and 90 meters west, and 80 meters south. So what I did is I went ahead and I created all of these, so that way I have all my vectors. And what I did is I made sure that these would be to scale, and so you'll be able to do that with a ruler. Your scale will be whatever you think it is, or whatever you think is going to work well. What I'm doing, and what I think you probably should do as well for my scale, is, and you'll see what I mean whenever I do it, that I'm going to say that for each of these, 1 meter, in terms of these meters, actually, nah, scratch that. We're not going to do it that way. We're going to do it the other way. That way there's no decimals. I'll make sure that it's nice, even whole numbers for you guys. Okay, so we are going to say that 10 of those meters up here equals, we'll make it real easy, 1 centimeter. And so that's what I would highly recommend you guys do as well, just to make sure that nothing changes. So if I was looking at 50 meters north, I believe that's this guy, so you'll notice that for each of mine, and this should be roughly to scale. Naturally, this one's a little bit off. Bring it down a little bit and see if that helps us. Okay, so, yeah, it's not bad. Okay, so that's my 50 meters north, because you can see it is 5 centimeters long. And so all I had to do is just move my decimal back one place. All right, so I'm going to start with 50 meters north. Doesn't matter where you actually place it. You just want to make sure that they're going to stay on your grid somewhere. So let's just, let's just start right there, okay? 50 meters north. Then from the end of it, because you had tip the tail, you're going to go 70 meters east. So naturally, you're going to take a protractor or a ruler. So you're not really using these as you're measuring. So the grid is just to give you kind of like X and Y coordinates, so that way you have something to compare to. So then I'm then going to take 70 meters east. And from the end of that one, notice I'm going from dead center of that. And let's just make sure that this is, yeah, okay. So 70, so I'm going to go basically from there to there, okay? And then I'm going to go 30 meters south. And then I'm going to go 90 meters west. And so I measured all these out ahead of time to make sure that they would work. So you can see that, like, how it's almost kind of going off the edge of the paper, so just make sure you're careful here, and lo and behold, check this out, I am going to go off the edge. So I don't want to start towards the bottom. You guys are not going to want to start towards the bottom for this one. And so once again, you just pick a spot where you want it to start. I started from there. And then lastly, I have 80 meters south. Okay, let's grab 80. Let's double check. 5 to 13, so that's 80. Okay, and I'm going to place that right there. And then I would have a resultant, and my resultant is going to go from start to finish. I don't know if I have any. Can I do it? No, can't do lines. There we go. Okay. Let's do a red line for my resultant. So my resultant is going to go from here. Wow, that's really thick. To here. Okay. Let me see if I can make this a little bit smaller. All right, and then I'm going to put an arrowhead on this as well, so that way we know from start to finish what it's going to be. Okay, window open up. So what you're going to notice is, while that's loading, so we started here, I first went north, then I went east, then I went south, then I went west, and then I went south. And so what we're trying to do here is we are trying to make it so that we're able to basically, let's see, ending style. There we go. Cool. Okay, that should do it, right? Yep, okay. All right, so basically what we want to do then is from start to finish. Now remember I said that I want you to measure your angle from east. So if this is my point, east is right here. So the angle I want you to measure is going to be this one right here. All right, and then you're going to take your ruler and you're going to measure the length of this. So I could grab my ruler over here. Let's grab the ruler. Let's rotate it. Let's see, that looks about parallelish. Not bad. Okay, and so I'm just going to put my ruler naturally. With the rulers, be really careful, because some of them, the zero doesn't start right on the edge, kind of like this one. Sometimes I might start at the 1 and then measure out. So this is then 1, 2, 3, 4, 5, 6.1, 2, 3, we'll say 6.4. Okay, So somewhere around there, let's call it 6.4, so we'll say it's 6.4 centimeters long. But then if I wanted to use this scale to go back to meters, remember you just move your decimal over 1. Okay, so that's how I'm going to get that measurement. And then this angle, you could get a protractor out and you measure it with a protractor. If you don't know how to use a protractor, I'll show you on the next slide. Okay, and actually it gives me an angle in here, but so we'll use the protractor on the next slide. So that's ultimately what you're doing for part A for route 1. Then for route 1 again, you're just going to rearrange the order of these and see if your resultant and everything matches. So just don't go 50, 70, 30, 90, 80. You could go 90, 70, 30, 50, 80, or 80, 90, 30, 70, 50, or 90, 30, 70, 80, 50. Doesn't matter. There's lots of different combinations you can use. So for route 1, no math. The only math is just this conversion. Okay. Route 2. Route 2 is one where you're going to have to do math, which is why I have slots for graphically measured and then mathematically calculated. So you're going to, once again, add these in order. This time you're going to draw them to scale with an angle measurement. So the first one, 80 meters. I'm trying to think which one of these was 80. I think this one was 80. I got to get off my pen. Okay. All right. So we're going 80. And what I'm going to do is I'm just going to, I know that's changing and everything, but with your protractor, this is supposed to be south of east. So your protractor, basically, you want this to be, since it's south of east, you want to flip it upside down. And the reason you want to flip it upside down is because then across the flat, you're going to come out east, and then you're going to go south of east to create your angle here. If I was looking at, say, like west of north, then I would do something like this. I would want to rotate it this way, because then I'm going to first go north, and then I'm going to go west of north. So this measurement, you're always going to go across the flat spot of your protractor first. And so notice that as you're looking at this, you want to make sure that the flat spot and this dot is going to be right, like wherever you're measuring your angle from for the protractors you guys are using is always going to be from the bottom of the metal, not the inside metal part, but from the bottom of the metal, so along the flat line. All right, so I'm going to go and rotate this back so I can get my exact angle. All right, and so this one I'm basically going to place it right at the bottom of the metal, and I'm going to estimate. Now naturally this isn't going to be exactly 80 anymore, but 30 degrees south of east, so you can see that's where the 30 is. We're going to say that this is 80, and so I'd have my first vector, and I would draw my first vector like that. And so I'd draw my first vector, and this is once again trying to keep them roughly the same. That definitely, yeah, it might be 80, close to 80. All right, next one, 50 meters north. That one hasn't changed, so then from the end of that, tip to tail, I would add on my 50 meters north. And you can use a protractor for that to measure out and make sure, once again, I'm doing 8 centimeters, 5 centimeters, 30 centimeters, 70, and then 90. And that's what you guys can do as well. All right. Then we're doing 30 meters, 60 degrees north of west. So this thing needs to be rotated. We're going north of west, so I want the flat spot to be on west, so I can go north of west. And let's go ahead and slide this down here. So this is going to be, apparently that's behind. Let's send that to back if I can. There we go. Okay. Now all these should be on top. Lovely. That's what I want. Okay. So I'm going to put this here. Let's go ahead and rotate this up a little bit so I have some space. Okay. So I'm going to put this once again on the protractor. And this is going to be 30 meters, 60 degrees north of west. So we're going west, and then we're going 60 degrees north of west. This is only 30, so we'll say about there. Call it a day. It's definitely more than that, but that's okay. And looks like that was going to take me over the page, so once again, be careful about where you start. Kind of get a rough idea as to where it's going to start so that you don't go off your page. Alright, so then I'd have this guy, which I'm going to drag over here if it cooperates. There we go. Okay. So that's 3 of my vectors drawn together. This is the graphical. You can see I'm a little off here. Be as exact as possible. 70 meters east. And I'm going to go off my page again. So you actually might want to rotate yours so that you're going to be going landscape as opposed to portrait like this. So you're not going to end up like me. I'm just going to keep going for what I got here. So I'm just going to be off my page here. All right, so 70 meters east, like so. And then this one is going to be east of south. So that means that this needs to rotate like this, because I first am going to need to go south and then east of south. See how that works? Okay, so I'm going to go ahead and take this guy and place the end there. And this is east, and this is south, but I'm going 20 degrees east of south. So here's south, and I'm going 20 degrees. See how I'm going to the middle angles there? 20 degrees east of south, and then this is going to be a length of 90. So I'm just going to keep it along that line just to make this the length of 90. So let's call that 90 there. Okay. So then I would add that to the end. This is why you might want to start like rotate your picture and start like way on the right side and then work your way across. So that might help you guys. All right, then my vector from start to finish. So as I draw my line in, I'm going to draw from start all the way to finish. Okay, and that would be my resultant. Now naturally I said I want you to measure with respect to east. So east once again would be right there. Okay, so I want you to measure that angle and then the length of this in centimeters and convert it back using your scale. The second thing you need to do is all your math, so make sure you do the math for this one as well. So create a separate triangle for each of the 5 vectors. Naturally, this one right here would not have a triangle, and this one right here would also not have a triangle. Okay. All right, Route 3, do the same exact thing you did in Route 2. So I'll do it real quick for you guys. So you're going to do 90 meters, 30 degrees south of west. So I'm going to take this one 30 degrees south of west. So I'd be at west. I'm going to come 30 degrees south of west. And once again, you guys would be using the protractor. You're not going to eyeball it like I'm doing. Okay, then you would do 30 meters south. Then you would do 70 meters east. Then you would do 50 meters, 25 degrees east of north. East of north, so that's north, so then therefore I'd go 25 degrees east of north, might be something like that. And lastly, 80 meters south. So your picture might look something like that. And then once again, you should draw from start to finish. And then you'd be finding angle from east, which is that guy right there. Okay, so measure in centimeters, convert back to meters, measure that angle with your protractor. So to measure that angle with your protractor, let me go ahead and select my protractor. So you can see that I'm going to have to take this guy and I'm going to have to flip it upside down. And I'm going to place it so that the initial point is right there. And then I'm going to measure where this line is kind of passing through, so I can see that this line definitely is not straight, but we'll say it hits about 85 degrees or so. And then you'll do the math and it should confirm both of these things that you got here. All right, so that's your goal with this lab, is to go through and do all of that. If you have questions, just email me.